implement this in DataPower, you need to build a AAA policy. That is the core object that would implement and enforce mutual TLS. However, that's not the only object that you would require in order to implement this. The very first thing is you need to generate two pairs of certificate. One that perhaps the client would use, another one which DataPower as a server will use. That will ensure the TLS connectivity. But in order to enforce mutual TLS and in order to authenticate and authorize clients using their certificates, creating a AAA policy is pivotal. So without further a delay, let's get started with creation of a AAA policy. We'll start with a brand new AAA policy. So we'll say AAA policy, click on the add. Initially, the AAA policy might look daunting. If you are unaware or if you are not sure about the AAA policy, watch my another video where I have discussed AAA policy in great detail. Here, I'm quickly going to create the AAA policy that we would need for this implementation. So I'm going to say test AAA policy 01. That's the only thing that you fill in the main tab. In the identity extraction, we are going to say subject DN from TLS certificate from connection peer. That's how it will extract the DN name from the certificate that comes as a TLS handshake. Now the authentication part, in here we need to say AAA file. So somewhere here you will have AAA file. Now you don't know how to put information in the AAA file. So AAA provides you a good tool to assist you in this. Click on this plus sign. Never fill any credentials in default credential name. Let's go to the next one. Here you define your identity. In our case, it is going to be coming from the client certificate and it is the DN name of the client. So click on the add button and here under DN we need to fill the client certificate name. But how do I fill the client certificate name over here? A good way to do this without much of the hit and trial is to upload your client certificate. You anyways going to need it under the cert folder. And you can see that I have here client self-signed cert, which I uploaded. Server certificate, it will be used for server. So client cert is my client cert. Click on details. And here you have the subject. So you copy this subject from here, but don't use it as is. Let's bring it to a notepad. And here you need to bring it in a / notation, which is simple. This is how I bring it into the / notation. Copy it and let us go back. So come back here. Perhaps there is one more window open. No, this is not the one. Let's go back to here. Yeah. So distinguished name, you fill this. And here under credential name, you can fill anything. I personally tend to put a credential name which belongs to a business object name or client name, a kind of a descriptive name. If I fill up here my name, that's also fine. But a good way, as I said, is to fill the client name. So I'm going to say here client 01 and would say submit. So under authentication, I have defined the distinguished name, the DN name of the certificate. But I haven't yet defined any kind of rule which says allow or disallow this user on any kind of resource. That I will specify next. So click on next. Under map credential, nothing. These are optional steps, skip them. Under authorize access resource, I'll say add. Now see, here I do not have to specify the certificate name. I'll specify client 01, the descriptive name, and the resource. So in this demo, I have two resources. One is employee and another is account. I want this client to have full access on employee, but no access on the account. And that's what I'm going to implement here. So for employee, allow. Okay, I would say submit. I'll again say add client 01, and we'll go back here. We'll say account and say denied. So on employee, you can say this client has full access, and on account resource, this client has no access. So even though the client is able to authenticate using its certificate properly, if the client tries to access account service, client should not be allowed. It should fail in authorization step. Now go to the next. Here, provide a name of your AAA info file. So you can provide it like this. Click on next and then commit. Done. Fine. So you have created a AAA info file over here. If you wish to view this AAA info file, remember its location. It is present in the local folder. Go to the credential mapping, nothing. Resource extraction, we will say URL sent by the client for this demo. Your resource mapping, none. Authorization, well, I have a AAA info file and I want DataPower to look at it. So go to local folder. Here I have AAA info file, and that's what the authorization. There is nothing else that I need to configure. My AAA policy is ready. In simple words, what this AAA policy says, it says whenever a client certificate comes as part of TLS handshake, the AAA policy will extract the DN name of the client certificate, and then it will try to authenticate it using the AAA info file, which says that if the DN name is listed over there, then it is correct, and it should be the and the authentication succeeds. Now, after the authentication succeeds, this AAA policy will check what resource client is trying to access. If the client is trying to access the resource called employee, it will allow. Otherwise, it will block the request. So that is what it will enforce. Fine. So we created the AAA policy, but this AAA policy on its own is not very beneficial. It must be attached with multi-protocol gateway, because multi-protocol gateway is the object that is going to receive requests from client. And here you will see second most important part that I'm going to do here. So let us create a AAA policy here. MPGW over here. We'll say test MPGW 001, and we will say it static backend. Why I'm saying it a static backend? See, I need to have some type of backend which will give us data associated with these services. The services like employee service and account service. So if you have a backend, maybe a kind of a API or microservice which gives you can put its address over here. But in a typical testing scenario, you won't have the access of that. So in DataPower world, what we create is we create mock service. In order to save time, I have created a mock service over here. So you can see I have an XML firewall which I'm using as a mock backend. Okay, in another video I'll talk about how to create mock backends. But here, assume that this mock backend is here, and it will have an IP address and port number, and if hit, it will provide you the data, the employee data or account data as required. Okay, and there is no restriction on this, meaning that there is no particular AAA policy that is attached with it. So it's plain and simple service. It is supposed to act as a mock backend. Now here I'm going to say default backend is the address of this XML firewall, the one that you're looking at here. So here I'll say HTTP and then IP address of that 192.168.1.1. I assume it is correct. And then the port number, what is the port number? It is 8000 that I specified, so say 8000. And then I'm not going to specify any URI over here. Why? Because URI will come as part of the request and will get appended on top of it. So this is the backend. Request response type. Request I will say non-XML, and response I know XML, because that's how I coded that XML firewall to return the data. Okay, so once these pieces are done, we'll focus on the processing policy, which is, let me create a processing policy. So first I'm going to create a bare bone policy here. So we'll say test mpgw001 policy, and we'll say apply policy. Here create a new rule, which is client to server rule. Here I do not want to differentiate between any kind of URI. So I'll say default URI, which accepts any URI that comes. Drag and drop results. Now this is the request rule. Now I'll create new rule. This is a response rule, server to client. In response rule, I don't want to do any kind of processing. I just want to ensure that whatever comes from the XML firewall gets returned back to the caller, and hence I need not have to specify any other processing action over here. What happens if I do not specify the response rule here? Well, by default, DataPower will block the request. Now this behavior might change from firmware to firmware, but I would suggest that for a predictable result, you create a response rule even though you do not intend to put any processing over there. This will ensure that DataPower doesn't filter or block your request by default. Anyways, let's go to the client to server rule. Here I need to enforce AAA. So drag and drop AAA policy, because we created the AAA policy in advance. So it is easy for me just to specify it. Now my bare bone policy is fully set policy. This is the complete policy that I need here. The major part that I wanted to show you here, which is required for this scenario, is creation of a front side protocol handler. And see how do I do that. First of all, you need to select HTTPS. HTTP won't work, because if I select HTTP, client will not send its certificate. It's no longer an HTTPS. So here we'll select HTTPS, and I select any of the last used name. Local IP address is fine. Port number, I will say 8003. And enable the GET request. Now important part here is configuring the TLS server profile. If this goes wrong, things will for sure not work. So here we'll select server profile. Now under TLS server profile, click on the plus sign. We'll say server profile 1, and here I would say identification credential. This is the place where you put the private key and the certificate of the server. So you'll say plus sign, and I would say DataPower ID cred, and here provide the key and the certificate. How do I do that? Click on the plus sign and say DataPower private key. Here under cert folder, you have server private key. This I generated using crypto tools. And then similarly, certificate DataPower server cert. Again, this is the server self-signed certificate. It got generated as part of the crypto tools. So I have crypto key and certificate. Click on the apply button. Again, remember this is a self-signed certificate. Now, shall I enable it? Yes. If I do not enable it, DataPower will not challenge the client. If it doesn't challenge the client, client may not send their client certificate. So it is important that request client authentication should be turned on. Remaining all, you can keep it like this. Validation credential, click on plus sign, and here say valcred01. Okay. Certificates, well, I need to upload the client certificate over here. Why? Because it is the trust store. So click on the plus sign and say my client list, or you can say trusted list. Well, hold on. Let me give it good name. Client 01 cert. And here, so if you look at this step, you would see that uploading your client certificate on DataPower file system under cert folder and encapsulating it into a certificate object is absolutely essential. Click on apply button. So this certificate is trusted now. Click on apply button. So my ID cred and val cred is set up. Click on apply button. My TLS server profile is good. Click on apply button. And you have the multi-protocol gateway all set up. So all in all, what this setup means, summary. You have just seen how to configure a MPGW. I have created a policy over here which has AAA, which means that it is going to check whether the request is clean and green from a AAA perspective or not. It has a front side protocol handler which will ensure that the handler challenges client for TLS and certificate, and the client must send their certificate, otherwise it will not work. And request response type is important. It's based on your application scenario. Now my multi-protocol gateway is ready. My mock backend is ready. So what I'm waiting for, let's get started and do the testing. Tool that I have selected here is curl. You might wonder, in other videos I prefer to use Postman, but here I have selected the tool as testing tool as curl. Why do I do that? Well, if you go to Visual Studio, you see that this is the Postman tool, and unlike its standalone version, there is no support for importing client certificate over here. In other words, this tool cannot send a request to backend where the backend expects client certificate. So if you have a standalone Postman, well and good, go ahead, use that. Else, curl is accessible to everyone. It's a simple tool, and it comes by default with Mac, so my MacBook has it. On Linux as well, this tool is available, and on Windows, it's easy to install. So that's pretty much. Now, so I'm going to fire the curl command from here, but before I go ahead and do that, I would like to show you that here we're going to see the view log. So we'll see the logs, and I would like to show you the log to prove a few things. And we can enable the probe over here as well in order to examine something that may go wrong. So let's enable the probe. Okay, just in case. I'm going to close this window. Now I need the testing URL. So testing URL, as you might have guessed, it is the testing URL for employee. I'll explain quickly. This is the curl command. -k means ignore the self-signed server certificate. Otherwise, curl will not work. This cert is the client self-signed certificate. And you can see that its extension is .txt. You might say, oh, you should use the PEM. Well, extensions are ridiculous things, okay? A file extension is not, it doesn't mean very much, right? It is a Windows concept that has been popular over a period of time, but originally the extensions do not mean much. So anything, I mean, .txt is also fine. Again, the private key, you have the private key over here. This is the client private key. And then you have the server URL. You can see this is the server URL, and this is the port number of multi-protocol gateway front-side handler, and /employee means I'm trying to access the resource employee. This is a GET request. Let's see, let's fire it and see what happens. If you don't remember, I would like to remind that this client has full access on employee, but the client does not have access on account owing to the authorization rule that we configured in the AAA policy. So this call should succeed, but the second call, which is on line number 12, should fail. Let us copy this and come back here, paste this command and run it. Now it says could not load PEM certificate from this text. It simply, so it might look like that it's a file formatter, but it is not. It is just that I'm at a wrong place. I am at a place where these files, this self-signed cert file and private key, do not exist. So these exist in my downloads folder. So let's go to the download and let's fire the same command. I'm using up arrow key and you can see, and now this command has been fired. It's going to DataPower. First time it would take a little while, but you can see that you are able to get the employee data over here. Okay, well, let's fire the second command. So in this second command, my expectation is that I would get some kind of error. Let's paste it. I'm trying to access the account and you can see that it says rejected by policy. Well, that message really is a good message. It is indeed rejected by the AAA policy, but how does a rejection looks like in DataPower? If you click on the view log over here, you can see here how it says AAA authorization failure, and indeed it is blocked by the AAA policy. Now to see it in a good way, let's go to the probe, and that was our first call which went successful. You can see in black color, and here it is the red call. You see that after AAA policy you have it blocked, and it is understandable why it is blocked. Now check this. Go to the context variable and try to see authenticated user. You can see that, which means DataPower is able to authenticate it and map it to a user name client -01, but AZ, you see this AZ step here, see the node, and it says decline. It declined in the authorization step. So here I have shown you that even if the authentication succeeds and but the authorization fails, your clients would be blocked and they will not be able to access any kind of resource. So this concludes the discussion related or demo related to the mutual TLS, where client certificate authentication is expected and how you can implement it using the HTTPS handler, MPGW, and the AAA policy combination. That's pretty much for this on this topic. Thank you. Thanks for watching.